We will discuss about the development of machining. This is a very old process. Machining means the removal of material from any surface. We remove the surplus material from any object. This machining process is very old, and it was started by the early men who used to make their tools and weapons out of stones, wood, and bones. In the excavation, we have found this type of tools. You can see even that period they were having a very high degree of skills. To see all these tools and weapons they used to make with the help of stones, and after that the people began to make tools of metals, and then they learned about manufacturing tools with hard materials like steels. Then this machining was automized. Significant development happened in the year 1770. During that period, the steam power engine was invented by James Watt, and then many renowned professors they came into existence and they introduced different automatic machines. They reduced human effort with the help of automation. Then that it came the era of these high speed machinings like drilling and milling, and you can see what is the level of precision, what is the level of manufacturing. They were able to manufacture the things in microns. And then is in today's world we have a new concept called micro machining. You can see the level of accuracy and the machine surface. Here there is a scanning electron microscope image of some contour slots cut from the surface. The scale length shows that the scale length is of 100 micrometer. You can compare the dimension of this cutout portion with the scale length, and you see that we are able to manufacture or machine parts of this length. In this particular figure, you can see that with the help of laser machining or electron beam machining process, what is the level of accuracy and what is the level of manufacturing. We are able to difficult to machine materials. What's the that's even very less. It's 50 micron. Size of the hole is comparable and it lies in the range of 30 to 50 microns. So this type of manufacturing we have achieved from this prehistoric age with the gradual development of technology and materials. This is a recent level of manufacturing. This is the nano manufacturing. And with the help of specialized machining process is one of the processes focused ion beam machining or ion beam machining process. You see what is the level of manufacturing. This is in the nanometer. This is scale length. It shows you that what is the scale of manufacturing. So this is, you see, it is 500 nanometer. So that means this particular length, this width is approximately 100 nanometer. And the size of this, you can say hole, this is approximately 400 or 500 nanometer. So with the advent of technology, now we are living in an age that we can process or make holes or do machining in the nano level, in the nano level. And I think I don't have to much explain about the machining operations, but from this particular slide, we can have a brief idea about machining. Machining is a subtractive process, and we remove surplus material in the form of chips. For conventional machining operations, we require two important things. One is the cutting tool, and then other is the machine tool. So what's the significance of a cutting tool? It provides a hard and sharp cutting edge, and whereas the machine tool provides a relative motion between the tool and the workpiece. For a cutting tool, there are many important properties like hardness, hot hardness, toughness, wear resistance, and chemical inertness. And there are many tool materials available in the market, such as high-speed steel, cemented carbides, cast cobalt alloys, cubic boron nitrides, and sometimes diamonds. And we have many basic machining processes like turning, drilling, milling. In fact, we have different types of turning process. We have in like facing, taper turning, contour turning, form turning, chamfering, cut off, threading, boring. And we can also perform this drilling and knurling operations on the same machine, which is a universal machine tool, and it is known as the lathe machine. In conventional machining, we remove the material in the form of chips that are in the range of millimeters to centimeters, depending upon the feed and the depth of the cut. And here we achieve a surface roughness of 1 micron to 12 micron or more. And then after that, we have finishing operations. In finishing operation, we have grinding operation. We have a grinding wheel, which is a multi-point cutting tool. And in grinding wheel, we have many abrasives that are bonded together with a suitable bond matrix. And it is not used for the material removal. Rather, it is being preferred for the finishing operations to make the surface flat and smooth. And in grinding, we can achieve a surface roughness of less than 1 micron. After that, we have super finishing operations like honing and lapping. In honing, we have a tool, special tool, which is known as the hone tool. And you see that there is a particular attachment which has these stones or the abrasive stones. And this honing tool can be rotated about its axis, and it has a very important application in the automotive sector. Honing is done to finish the cylinder bores, and we can achieve a surface roughness of means 1.13 micron, or you can say it is close to 100 nanometer. And then we have a further super finishing operation, which is known as the lapping. And in this particular process, we use a lapping tool, and it is a soft metal. And then we sprinkle some loosely bonded abrasive grains on the surface, suspended in a slurry. Then we rub this lap over the workpiece to be finished in the motion of 8 figure. So here we can achieve a surface finish in the range of 0.08 to 0.25 micron. It has a very important application in the manufacturing of optical lenses. Means the surface of the optical lens are finished, or they are made super smooth with the help of a lapping process. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.